All right, we are ready for question 92, which is a follow-up to our cube modeling activity. So this question here asks, what happens when a warmer object comes in contact with a colder object? We've addressed this a couple times, but we should probably write something along the lines of, I guess I'll jump over the notes. Energy transfers from the warm object into the cold object until they reach the same temperature. I'm going to throw in the vocab term equilibrium there. So energy is transferred from the warm object into the cold object until they reach the same temperature, which is equilibrium. All right, question 93. When you're considering whether the system is at equilibrium, should you look at the average kinetic energy, which is the temperature, or the total kinetic energy, which is thermal energy? So, what do you think right now? All right, the answer here is you should look at the temperature. Next, which would be the average. So, temperature or average is the answer. Here, how does the number of molecules in the object affect the thermal energy, the total kinetic energy of an object? So I'm going to say the more molecules we have, the more thermal energy we have. Just because there's more molecules to add together, that means we're going to have more thermal energy as a whole. So here's the answer for the second part. Here's the answer for the first part. Go ahead and fill that in. Delete these out. Okay, question 94. Temperature versus thermal energy. Does the amount of substance, either the total mass or the total number of molecules, affect the temperature, or does it affect the thermal energy of a substance? Okay, so the amount of a substance affects the total thermal energy. Temperature is unaffected by the amount because it's an average. So when you're doing the temperature, you're dividing by however much you have. And so the amount does not affect the temperature. The amount that you have only affects the total thermal energy. So some examples of how this applies. We have 2 beakers of water, both at 110 degrees Fahrenheit. Beaker A has 1 liter of water, while beaker B has only 0.3 liters of water. Both have the same temperature because they both have the same average molecular speed. They're both 110 degrees, but beaker A has much more thermal energy because it has more mass. It has almost 3 times the amount of mass, so it's going to have 3 times the thermal energy as the other beaker. All right, the next activity is the second part of the energy cube model. I have a separate video for this, so we're going to use the energy cube model to help us think about what determines how much an object will change temperature. Will it change temperature just a little bit or a lot? And that depends on the size of the objects. So in part 2 of the energy cube model, the goal is to show what happens when a former object comes in contact with a colder object. So go ahead and complete the 2 trials. In part 2, you can get the access to this video right here before question 95.